5 minutes after Mindy died trying. Get it? Died trying. Literally died trying. Bryce finally understood fractions.
Was she trying to teach him or was she trying to learn it herself? Dog? Teach.
No, it's her hair on the table. Okay, so adding and subtracting. So when we add and subtract, right, we need a common denominator. So we're going to look at where we're dealing with binomial denominators today, and they maybe don't have anything really in common. Or maybe they have one thing in common, but not everything in common. Okay? So here, write the lowest common denominator of the two rational expressions as a product. So in this case, when the binomials are completely different, the lowest common denominator would be both of them, x minus 5, and it would be a product of the two, times x plus 1. So you'll notice that this one's partially worked through. So we basically, they already have, this is the answer. We're going to show that this is the answer. So here, we're missing which guy? The first fraction. Who's he missing from his denominator? X plus 1. This is our, right? He already has x minus 5. So we multiply top and bottom by the x plus 1. We did this yesterday, right? Look at it in more depth. And then the second fraction, who's the denominator missing? X minus 5. So multiply top and bottom by x minus 5. Now, it's very important. I would write the next step. Before you actually start expanding, write it all over one denominator with that same operation in the middle. Now, you have to be very careful with subtraction. So what we're going to do with subtraction, we're actually, even though we're going to expand this, we're going to keep the brackets when we have subtraction. So we're going to expand, but keep the brackets. So what did they do to get this? They FOILed, right? So it was 2x times x. You with me, Stacy? Yeah? Okay. And then 2x times 1, and 1 times x, which gives us 3 x's, a 2x and a 1x, and then a 1 times 1, right? So they FOILed both of these. Now notice that we want to keep the brackets even though expanded. Why do we keep those brackets? Because the sign in the middle applies to everything it's subtracting. That's second polynomial. Yes? Yep. So x times x times -5, right? So that's how they got that. They FOILed it out. And so keep the brackets because actually, maybe it's like that, but I'll just write because. Because the sign in the middle, I like how you said that, Kristen. The sign in the middle applies to every term in the second binomial or trinomial. Every term in the polynomial we are subtracting. Does that make sense? Every term in the polynomial, a lot of writing, I'm sorry, we are subtracting. Okay, so how are we going to rewrite this? We want to get rid of these brackets so we can collect like terms. So how do we apply this negative to everybody? Yeah, Tamara? Yeah, distribute. What number is in front of here? It's like a -1. We're going to distribute the negative. We're basically switching all the signs to change it into addition. So now we can write it without the brackets. 2x squared plus 3x plus 1. And then what will we have? The x squared becomes a minus x squared. Yeah, that's a 3. -1 times -9x will become what? A positive 9x. Can you see that, Priscilla? Do you want to move maybe? Why don't you move? There's like all those areas that might be a little easier. And the positive 20 becomes a negative 20. And now we collect like terms. Okay, so let's collect like terms. Brad, are you awake? You okay? You're already done the question? No? Yes? Okay. It's Friday. Just got to get through 2 more classes. Then you're free. Okay, let's simplify. 2x squared minus x squared. X squared plus 11. 12 I can add. Yep. Plus 12x and 1 minus 20. It's a 9. Okay, positive 1 minus 20. Negative 19. Now, is that factorable? Let's check. Okay, are there 2 numbers that multiply to negative 19 and adds to 12? Well, let's look at, how do we multiply to 19? 1 and 19. Is there any other way? No. Does that add to 12? Can we make it add to 12? No. So is it a factorable? No. Okay, we're almost done. Last step then is to state non-permissibles. X can't be 5 and negative 1.
I think all the questions.
Yeah? Let's look at a couple questions. We're not going to do every question in this lesson. We're just going to do a few of them. Let's look at number 1b. I'd like you to set up the very first step. Okay? So we want them over the same denominator, 1b here. Okay? You try that first step. Can you work on this, please? Stay with us, okay? I know. We're not gonna spend a lot of time on it. Just a little bit, okay? Just that extra practice. Because subtraction is where we make our mistakes. Got it? I'm noticing a lot of you. Can we go straight to writing it under one common denominator? Yeah, a lot of you are. So the first one, what is missing? The y minus 3. What's missing from the second one? Since we can't factor here, that's why we can go straight to this. 2y plus 5. So a lot of you are going straight to this step right over here, which is awesome. You're totally welcome to go straight to 4 times y minus 3 minus 1 times 2y plus 5. Make sure you have your brackets there. All over the common denominator.
So I was like, how'd you get it?
My 4 looks like a 9, sorry.
Can you at least just put that tail out further?
Like that?
Yeah.
Oh, that does not work. How about I just write it like that? Okay. Sorry. Okay, so simplifying the numerator. How do we do that? What's it called? What's it called when we bring in a number? I heard it. A little louder. Distributive law. Okay, we're going to bring in the 4, and we're going to bring in what? The negative 1. The negative 1. Yeah. Okay, 4 times y. 4y, 4 times negative 3, negative 12, negative 1 times 2, negative 2y, negative 1 times 5, minus 5, all over our common denominator. Can we simplify this? Yeah. What does it give us? 2y minus 17. Is that factorable? No. 17's prime. And y can't be equal to negative 5 over 2 and 3. Good. Getting easier? Yeah? Okay. Let's look at, we're basically going to look at one more example. Okay? And then you can practice homework. Let's look at, maybe, yeah, we'll look at one more. Oh, maybe that one's nice too. Let's look at 2b. So turn over to 2b. 2b. Okay, now the questions we looked at before, they couldn't be factored, right? So that's why we could go straight to finding a common denominator. Can something be factored here? Yeah. What? X. We can factor out an x. Where does the x go when we factor it out? Where does it go when we factor it out? Out of the bracket. And we're left with x plus 2. Plus 2. Okay, so let's, what's going to be our common denominator? X plus 2 times, times x, right? We want to make them the same. This guy already has an x, and this guy has an x. So this guy's just missing what? X plus 2. So how do we give it an x plus 2? Multiply top and bottom by x plus 2. You could write multiply by 1 or just leave it, right? Because it already has that denominator. So now they are the same. So can we go straight to writing this all over x times x plus 2? Yes, ma'am. So the numerator becomes 1 times x plus 2. We could just write x plus 2 and minus just 1. Now, if this was a binomial, what would you have to include? Or a trinomial, or there's more than one thing here. Because it's subtraction, we have to be careful. You'd still need, like what if this was 2x minus 5? Thank you, Jesse. You'd need brackets. You would need brackets. It's not, so do you need brackets because it's a monomial? No, right? Because it's only applying to just that guy, so you're not going to make a mistake. Okay, so what does that simplify to? X plus 1 all over x times x plus 2. MPVs. X can't be negative 2 and 0. Good. Okay, so your homework today, you're going to have more time to work. Yesterday you didn't have too much, so some of you might have to finish the homework in the book. I'm going to assign you for today the following. So turn the page. Okay? So I'd like you to complete the following. A, C, and D. I will also write on this. Wait, why don't you circle them? Yeah. Circle the ones you have to do. Okay, 1A, I could write it after. 1ACD. 2B, actually. 2B. And 2, I'd like you to do a subtraction there, D. Sure. D. Number 3. Please complete the following. I'd like you to do 3A, B, and D. But they're not that bad, trust me. A, B, and D, turn the page.
They're all minus. Serious? Why would you do that?
Okay, sorry. 4, I would like you to complete one A and C.
There you go. Thank you.
You're welcome.
Just because I spaced out?
Partially. Ooh, I really like 5A and B. Let's actually do 5A and B.
5A is too easy. Just give us B.
Okay, 5A and B. No, it's not too easy. These are not the same. How do you make it the same? Okay. 6, you can do, and then do the multiple choice. So do 6, 7, and 8. Okay? Now, we have lots of time to work today and practice this. You have tons of time. So, yeah. If you have to finish, some of you might still have to finish. Guys, some of you still have to finish yesterday's homework. Some of you can go straight into this stuff. Maybe you want to work on this, and then you can go back. It's really your call, but I really want you to practice this addition and subtraction. It's really important. And, yeah, we're good? We're good to work quietly and efficiently? Awesome. Okay, you're welcome to listen to your music if you'd like to.